Lens maker's formula. We have certain assumptions while deriving the formula for lens maker's formula. The thickness of lens is very small so that optical center is close to the surface. The aperture of lens is small. The incident and refracted rays make small angles with the principal axis. The deviation produced by the lens is similar to that produced by a small angle prism, that is delta equals to A mu minus 1. In lens maker's formula, finally, we obtain a formula 1 by F equals to mu minus 1 by R1 plus 1 by R2. What actually this means? We can make a proper choice of refractive index. We can take a material of our proper need. We can choose surfaces of different radius of curvature or same curvature, one concave or one convex or both concave, whatever else, in order to achieve our required focal length. By the proper choice of material and surfaces, we can get the length of required focal length. That's why this is called lens maker's formula. Here we have a lens. A ray of light parallel to the principal axis is refracted in the way as shown. Okay, this is the direction of incident ray. This ray of light is parallel. Okay, this angle is beta, which is equal to deviation. This beta is equal to deviation because this is the direction of incident ray and this is the direction in which the ray of light is going. That's why this angle is equal to deviation. That's why this angle beta is equal to this angle beta. Okay, this is focal length O dash. This is height h at which a ray of light falls on the lens. Okay, let's take a point T. Q and R are 2 points on the lens, and we draw tangents from points Q and R, so that we get small angle prism. Okay, this is same figure. Okay, from right angle triangle, tan beta equals to h by f. Since beta is very small, that's why tan beta equals to beta, and beta equals to h by f. Tangents are drawn at points Q and R. They meet at point T and form a prism of a small angle A. The deviation produced by a small angle prism is delta equals to A mu minus 1. H by F equals to A mu minus 1. That's why 1 by F equals to A by H mu minus 1. Again, we draw same figure. This is same figure. This is first surface and second surface. C1 and C2 are center of curvatures of first and second surface. R2 and R1 are the radii of curvature. Okay, we join C1 and Q. C1 and Q. What happens? Okay, this is a part of sphere. Lens is a part of sphere. Let's say this is center and this is tangent. When we join tangent and line passing from center, those two lines are perpendicular to each other. That's why this C1Q is perpendicular at point Q. Similarly, C2R is perpendicular at point R. C1N1 and C2N2 are normals to the surfaces at points Q and R. Let's say this angle is alpha 1 and this angle is alpha 2. Alpha 2. This is equal to angle of prism A. A. These two angles are also equal to A. How will we see this one? Okay. These two angles are 90 degree, 90 degree. This angle is 180 degree minus A. This angle is 180 degree minus 180 degree minus A equals to A. Okay, now alpha 1 equals to h by r1 and alpha 2 equals to h by r2 because tan alpha 1 equals to p by b, and since the angles are small, that's why tan alpha 1 is nearly equal to alpha 1. A equals to alpha 1 plus alpha 2 from geometry. A equals to h by r1 plus h by r2. A by h equals to 1 by r1 plus 1 by r2. From 3 and 4, we substitute the value for A by h, and we get 1 by f equals to mu minus 1, which is lens maker's formula. Please follow our Facebook page, Physics with Physics, for more videos. Thank you.